Good morning, my name is Nicholas Richardson, and this is a brief presentation on my summer internship with Shell. I was interning at the Deer Park Refinery for Shell, working in the process department, and my project this summer focused on exchanger fouling within a diesel hydrotreating unit. And so just a bit of a content overview for this PowerPoint. We will have a problem overview, we'll then look at my methodology findings, and the recommendations, and lastly, key learnings from my internship this summer. And so the exchanges I'm looking at were fouling in a diesel hydrotreating unit. And a hydrotreater uses hydrogen to crack oil and remove any sulfur out of the diesel. And so my exchanges are the last two exchanges of the unit, and it's very rare to see fouling this late in a unit, just because after it leaves my exchangers, it goes to the tanks to be sold. And so I initially thought, okay, the fouling is coming this late in the game, maybe due to water quality. And so I first went and looked at, we should probably test the water. And so just a little bit more of a background. The exchangers I'm looking at are 722 and 1422 exchangers. They're in series. 1422 is a 6-pass exchanger, while 722 is a 2-pass exchanger. And so I met with our contracting company, Nalco, and asked them to take a sample of the water, the inlet water, going into the exchangers to see if it's a problem with our water quality. And Nalco took a sample of the water and sent me the results between the tower, cooling water tower 10, and another tower, and showed me that the results are nearly identical. So the water being fed to the exchangers is not a problem. The quality is fine. It's within testing error. And so that led me to believe that the problem was next with our exchangers. And so I began to meet with the operations support engineer for the hydrotreating unit to talk and see what was the problem with the exchangers. And what I noticed from gathering data and putting together the graph that you see here, we're seeing that we have extremely high skin temperatures and extremely low velocities, which is the perfect formula for fouling within exchangers. So we set our exchangers to be, the highest we wanted them temperature-wise to be was 130. But yet we have temperatures going into almost the 160s. And then our velocity was extremely low of cooling water, so far as half a foot per second. And so from the low velocities, I began to realize, okay, if it's not water quality, then let's talk to rotating equipment and seeing is it actually the pump data. And the pumps had recently been overhauled, so the pumps were operating fine. So it was just a combination of things that caused this fouling. And as you can see here, some of the pictures of the fouling that we see, especially on the right picture, that's a lot of fouling on the outlet side of the exchanger. So 1422 exchanger, the fouling is not coming on the inlet, it's coming on the outlet. And then you see here in our 722 exchanger, the fouling happens on the inlet. And so we believe that it was a lack of cleaning that caused the exchangers to foul this way and actually caused us to reduce our rates. So generally, DHT runs at almost 50,000 barrels per day. During this time, we had to reduce our rates to 36,000 barrels per day, which cost us an average of $2 million per day, just due to the high margins of diesel at the time. And so my recommendations were to continue using these exchangers because they're running fine now that we have cleaned them and overhauled the pumps for 50,000 barrels per day. And in the future, if we increase the hydrotreater's capacity, meaning that we ran more than 50,000 barrels per day, we recommended repiping the fin fans to the exchangers just to decrease the stress on the exchangers. And so I then began to work with a computer modeling program called Pro2 and successfully modeled the whole entire unit as it would actually work in the field, and successfully added a fin fan and got the chemical compositions all right and had it perform the way I wanted and actually decrease the temperatures before going in to the exchangers which would reduce the fouling rate significantly. And so my personal key takeaways this summer were to not always be satisfied with the first idea, to explore every option, which is rare, which is a different learning experience, because as a college student in school, we learn that there's a problem and generally there's one way to solve the problem. However, in the field, there's never just one way to solve the problem. They like engineers to question everything and look at every problem from every different angle. And I learned that the great way to learn is by leveraging knowledge of technical experts. So coming out of school, I have a lot of theoretical knowledge, but I don't necessarily have the theoretical wisdom that older engineers may have. And so meeting with them caused me to learn quite a bit and actually helped my project out. And then lastly, I learned that I must stay aggressive in communications, because everybody who's working is always busy, but you have to not allow you have to make sure that you get your point across and get your project taken care of as quickly as possible. And then lastly, I learned just how to work in team, as you see here, just other interns. I became part of a family of interns for this site, and so working together was a fun experience. And then I also learned about our flagship goal at Deer Park, which means that we want to be the #1 refiner within the Shell network, so that we can show the rest of the company how we run and how they should run also. And that is it. Thank you for watching.